Hello and welcome to Forbest Academy, and welcome back to our AMC 1012 preparation videos for the 2021 contest. Today we are going to be looking at our final AMC 12 question of the week, breaking down the concepts involved and looking at how to solve it. So our question for today: if the sum to infinity starting at 0 of cos to the power of 2n theta equals 5, what is the value of cos 2 theta? Now, the first thing we need to do in a question like this is I want to have a look at what this sequence of cos 2n theta looks like. So if we're starting n is equal to 0, we've got cos to the power of 2 times 0 theta, so that's going to be cos to the power of 0 theta. Our next term would be n is 1, so cos squared theta. Our next term, when n is equal to 2, is going to be cos 4 theta. We should be able to recognize at this point that our series is advancing by multiplying by cos squared theta after each term. So cos to the power of 0 multiplied by cos squared theta gives me cos squared theta. Cos squared theta multiplied by cos squared theta gives me cos to the power of 4 theta. So this is a geometric sequence because we're multiplying by a common ratio each step. And we also know that cos theta must be, the absolute value of cos theta must be less than 1. Therefore, the absolute value of cos squared theta must be less than 1. So we've got a geometric sequence here where our common ratio, the absolute value of it, is less than 1. There we go. So that means this is going to be a converging series, which means we can sum to infinity using the formula a over 1 minus r. Now if we substitute in our values here, a is cos to the power of 0 theta. That's going to be 1 because anything to the power of 0 is 1. And our common ratio is cos squared theta. So 1 minus cos squared theta. And we've been told that is equal to 5. So what we need to do now is we need to do a little bit of rearranging to try and get this in the form cos 2 theta. The first thing we're going to do is we're going to multiply it by 1 minus cos squared theta to get our value here. Now, we need to know some identities to be able to change our cos squared theta into cos 2 theta. And what I'm going to do here is I'm just going to run through a couple of identities to remember that are very useful for finding this. Now, the first one that I always remember is that cos 2 theta, not cos squared theta, cos 2 theta is equal to cos squared theta minus sine squared theta. Now we should know as well, we've got our another identity that is 1 is equivalent to cos squared theta plus sine squared theta. So if I rearrange this second identity, we can get that sine squared theta is equal to 1 minus cos squared theta. And if I substitute that into this into my identity for cos 2 theta, we will get cos 2 theta is equal to cos squared theta minus 1 minus cos squared theta. Or if we rearrange that slightly, that is equal to 2 cos squared theta minus 1. That is cos 2 theta. So we want to do a little bit of rearranging here because we want to replace cos squared theta in our equation over here. So what we need to do is we need to take this identity that we've just formed. Cos 2 theta is equal to 2 cos squared theta minus 1. We're going to quickly rearrange it to get cos squared theta is equal to cos 2 theta plus 1 over 2. Now, if we go back to our question over here, if we make another step in our rearrangement here, just to make our equation look slightly nicer, we can have 4 is equal to 5 cos squared theta. And then if I substitute in our value of cos squared theta from our identity into our equation, we're going to get that 4 is equal to 5 multiplied by cos 2 theta plus 5 over 2. But multiplied by 2, we will get 8 is equal to 5 cos 2 theta plus 5. Subtract the 5, we're going to get 3 is equal to 5 cos 2 theta. And dividing by 5, our value of cos 2 theta is equal to 3 over 5. Which is our answer, D. Thank you very much for watching this video. Please like and subscribe below. And don't forget to tune in again next week as we go through some AMC 10 past paper questions. Thank you very much for watching. I look forward to seeing you again next week.